You're watching Power Nation.
In today's episode of Engine Power, we bring back this big inch monster Mopar for some big changes and some big gains in the power department.
We're going to give this power plant a significant bump in compression, a new but classic look, and an induction package fit for 505 cubic inches before we test it all out in the dyno cell.
Hey everyone, welcome to Engine Power. Today is going to be another fun build because it is another engine we have pulled out of the rafters to revamp for a current project in the building. We love building Chevys and Fords, but we also love building the Mopar variety. And this one we are particularly fond of because when we built it first, it made great power. It just needed a home. Well, today is its lucky day.
This is one of our favorite Mopars. It is a 505 cubic inch big block, so it is a 440 RB base with a fully forged stroker rotating assembly, trick flow induction, and a big solid roller valve train. This thing made some serious pump gas horsepower the last time we had it on the dyno, and we're going to be making some upgrades today. But before we get to that, here's a quick look at everything that's already inside this power plant. This engine was originally sourced from a parts car out of Alabama, and after disassembly and machining, it was fitted with a 4250-stroke crankshaft from the 440 source. That, along with 7 100-inch long H-beam rods and 4 350-bore forged pistons, increased the displacement to that 505 cubic inch number.
It was fitted with a custom ground comp cams solid roller camshaft and sportsman lifters, and topped off with trick flow 270cc PowerPort cylinder heads. Trend push rods and a Harland Sharp shaft rocker system round out the valve train, and it is topped off with a trick flow track heat single plane 4150 intake manifold. With a QFT black diamond carb, this engine made 664 horsepower and 646 pound-feet on 93 octane pump gas.
So a great combination that made great power, and today we are going to refresh it, revamp it, and restyle it for the guys in Detroit Muscle.
Now we're going to get it apart and see what it looks like on the inside, but we're going to make a few improvements. Namely, we're going to update the piston, and we're also going to update the intake manifold. We're going to go with a Dominator flange. It's going to give us a little more airflow, a little bit more power. Plus, we are going to style it for looks. We are going to repaint it the proper Mopar orange, and we're going to put on some nostalgic looking valve covers. It's going to be perfect for the project. So let's get this thing apart and see what it looks like.
Starting at the top, we can unbolt and remove the distributor before loosening the 4 intake bolts and pulling the manifold with little effort. Once the valve covers are removed, the shaft rocker arms come next, so the engine can be rolled over to a point where one side of the engine has valves that are mostly closed and none at full lift. This reduces the spring pressure being applied to the shaft and the fasteners as we loosen each ARP bolt incrementally to keep the pressure even across the assembly. Once all the bolts are loose, the entire assembly can be removed.
All of the push rods are removed, inspected for abnormal wear, and kept in order in this handy Summit Racing organizing tray. The heads have to be removed before the lifter valley tray, so all the ARP head studs are loosened from the outside in. The nuts and washers are removed, and the studs unthreaded from the block to keep aluminum from getting grated into the threads and make it easier to lift the heads off. Ooh, look at that, like an engine should look.
Pretty good.
Looks awesome.
The lifter cover is bolted down and sealed with RTV, so a bit of cutting and prying is required to get it off and get access to the lifters. The solid roller units are slid out, checked for wear, and kept in order with the rest of the valve train. Moving to the front of the engine, we can unbolt the electric water pump and remove the oil pump housing that bolts to the front driver's side of the block. Before we forget, we'll drain the oil from the pan.
Then we can remove the bolts and drop the pan, or so we thought.
Whoa!
See, I used ninjutsu on that, you see that?
Yeah, the windage tray being sealed to the pan took a little work to get it off, finally.
Pat finally got to use his iron palm technique on it. The Summit Racing Harmonic damper is removed with a puller, and then the timing pointer and timing cover can be unbolted to reveal the timing set. After removing the cam gear bolts and timing set, the big solid roller bump stick can be slid out. It has specs of 260, 272 for duration at 50 thousandths lift, a 112 lobe separation angle, and valve lifts of 670 thousandths on the intake and 678 thousandths on the exhaust. The oil pump pickup threads into the block and was installed with thread retaining compound, so after a bit of reefing on it, it can be screwed out.
The ARP 8740 rod bolts are loosened for each crank throw. Caps are broken loose with a rubber mallet, and then the rod and piston assemblies can be carefully pushed out of the bores. With all 8 removed, the main studs are loosened, nuts and studs unthreaded, and the caps wiggled out of the block before gently lifting the 4-250-inch stroke crank from its bearings.
Very lightweight crankshaft.
With our 505 torn down, up next, we'll give it a traditional makeover and show you how a simple change can make a big difference in the balance of your engine. The first thing we're going to do to our 505 Mopar is give it a facelift with a new color. So we have all the parts we're going to be painting here in our prep booth, including our new intake manifold, new valve covers, and the oil pump because it bolts to the side of the block. Everything has been cleaned, taped off, and hit with a base gray coat. The color that Detroit Muscle chose for this project is Chrysler HEMI Orange, and we also are going to be painting the block. Before we got this ready, we gave it a quick ball hone job because the cylinders were aero straight. They were in good condition, but we wanted to give it a fresh surface finish for our new pistons and rings to help them seal. Then we got it fully cleaned, prepped, taped off, and hit with the same base gray coat. So all we have to do now is turn everything orange.
This color pays a bit of homage to the high-performance 440 Mopars of the 60s, which were painted HEMI orange instead of the blue found on the milder engines. The paint is P.O.R. 15's engine enamel, which can be brushed or sprayed and lays out in a nice, smooth and glossy finish. Under the hood, this engine will look as good as it runs.
All right, so with our block and parts fully painted, we're gonna let them sit and cure fully before we touch them, and that will give us time to balance our crankshaft and get the rest of our engine ready for assembly. The only part that we're really changing in the rotating assembly is the piston, but we still need to balance the crankshaft because using a different piston, it's gonna weigh a bit different. Our old piston is a great design and worked awesome for the application. It has a mild dish to it, which is perfect for the street application it was intended, made of 2618, and comes in at 817.5 grams, which is pretty usual for this size and application. Our new piston is a little bit more of a racy design. It is made of 4032, but it has a little more of a flat top design and is a little bit lighter, coming in at 699 grams. So 118.5 gram difference, which when you're talking about the balance of a crankshaft is relatively significant. And that's why we need to put it on the machine, check the imbalance, and bring it within our tolerance. What we're gonna do is do our first spin, see what we're dealing with, and then we'll figure out how we're gonna correct it.
The bob weight for our new setup comes in at 2,149.6 grams, and with CWT Industries calibrated bob weights installed with that metric, we can see our starting point.
That's actually pretty good and to be expected. So we can see that the imbalance on each plane is really close to 180 degrees out, which means that it was correctly balanced before. We're just changing the piston, so the weight is changing. And so we are at 47 grams on the rear and 71.9 on the front. So we have quite a bit to take off. The best way to do that, since this crankshaft's already been balanced once, is we're gonna put it in a lathe, we're gonna turn the counterweights down a little bit, get our imbalance down to a more manageable level, and then we can come back with the drill and fine tune it in. We can turn the 1¼ inch wide front and rear counterweights down, doing it in stages while checking our work a couple of times, since it's always easier to remove material than it is to add it back. In total, we took 160 thousandths off the front counterweight and 100 thousandths off the rear in the lathe. Okay, so with just turning the counterweights down, not drilling any holes, we've already got it down to below 16 grams of both the front and the rear. So we're much closer to our goal. Now we can come back with the drill and get it dialed in. Even though we have taken a large chunk out and the imbalance is around 180 degrees apart from each other, that 15 grams will create almost 150 pounds of force at 6,500 RPM. So we were able to use the existing holes in the crankshaft, the CWT drill head, a variety of drill bits, and some deep creep to quickly bring our imbalance under our tolerance of 0.150 ounce-inch for this heavier forged crank. All right, that is very good. Probably better than it needs to be, actually. 0.051 ounce-inch on the left, 0.079 ounce-inch on the right, well within our tolerance, 190 degrees apart. Forces on the center of the crank minimized down to 0.030 ounce-inch. So very, very good. We'll save that as our last spin. And we can look at the forces on the crank from before and after. So on the front of the crank, just at 6,000 RPM, before we balanced it, there was going to be 588 pounds of force on the front of the crank. And now at 6,000, we've minimized that down to just 5 pounds. So literally more than 10 times better. And that is, again, every time we show you this, why it is so important to have your assembly balanced, even if you're making just a little change like the piston. So very happy with that. We'll get this off, we'll get it polished up, cleaned up, get everything ready for assembly. And the next time you see this, it'll be going in that engine.
You heard him. Up next, we thrash to get this big block Mopar reassembled to see how much power we gain in the dyno. We have our Stroker Big Block Mopar block looking good. We went ahead and checked all of the bearing clearances beforehand. The mains have come in at 27 to 32 10,000ths of clearance. For a high performance application, we like to use a clearance level of 1,000ths per inch of shaft diameter. So at a 2,750 main, we are right in the ballpark.
Yeah, and we also went ahead and did the rods as well, and with new bearings, those all come in between 27 and 29 10,000ths. We also check rod bolt stretch while we're at it, so we are pretty much ready to go and click this thing together.
Firstly, all the main bearings receive some Hot Shot Secret assembly lube, then the rear main seal is installed and lubed.
Here we go.
Lifter in there, followed by the freshly polished 4250 stroke crankshaft. Each main cap is slid over the studs in the correct orientation and tapped down gently with a soft mallet. After preloading the crank to the forward position, the ARP main studs are torqued in 3 stages to 110 pound-feet from the inside out.
The rear main seal uses a separate aluminum housing, and rather than use the original square cut seal that's prone to leaking, we have added a bead of silicone between the block and seal housing, since this is the most effective and long-lasting solution. This is a custom ground solid roller from Comp and has specs of 260, 272 at 50 for duration, a 112-degree lobe separation angle, and valve lifts of 670 thousandths on the intake and 678 thousandths on the exhaust with our 1.6 ratio rocker and our 20 thousandths hot lash. The double roller timing set slides on in the 2-degree retarded position, and the thrust button is installed behind the cam gear bolt.
All of the rod and piston assemblies have already been assembled and the rings installed and lubricated, so we can install just the number 1 piston for now to degree the camshaft. Since we inspect the larger intake manifold to raise our peak horsepower RPM, we'll install the cam 3 degrees advanced at 109 degrees. The other 7 rod and piston assemblies can be punched into the block, and then the engine can be flipped over and the rod bolts torqued to 85 pound-feet to achieve the proper bolt stretch of between 5 and 5.5 thousandths.
We repainted the timing cover to give it a fresh look, and it goes on with ARP hardware and the stock timing pointer. The Summit Racing damper can be reused and pressed on with the proper installation tool. The oil pump pickup threads into the block on these engines, and some orange thread retainer will ensure it can't vibrate loose. After checking our oil pump pickup to pan clearance, and it's 3/8 of an inch, we can seal the pan baffle to the engine with a steel shim gasket that has a thin spread of silicone on both sides, and some more at the mating surfaces of the block to guarantee no oil leaks. A Summit Racing one-piece oil pan gasket seals the freshly cleaned 7-quart Milodon center sump oil pan that is designed for A-body Mopars.
The engine can now remain right side up, and a new Melling high-volume oil pump we painted can be gently slid into the block. On the top side, the oil pump and distributor drive shaft can be slid in, and the bronze gear meshed with the camshaft. The lifters come next and are dunked in engine oil for lubrication before sliding into the lifter boards they came out of. They are covered up by this very trick flow valley cover that eliminates the stock belly pan and is sealed on with RTV and tightened with the 6 button head screws.
Okay, we are ready for the induction on our 505 Mopar, and like we said, one of the big changes we're going to be making is moving from TrickFlow's Track Heat 4150 manifold to their 4500 manifold. And this not only allows us to run a Dominator style carburetor, it also has a larger plenum volume and a larger runner cross-sectional area to better match our cylinder heads. These are TrickFlow's PowerPort 270 for the big block Mopar. These have a 270cc intake runner, a 2190 intake valve, a 1760 exhaust valve that's housed in a 78cc combustion chamber. These flow 352 CFM at 700 thousandths inch of lift. so they are pretty much the go-to for making big power with big inch Mopars. Ours are outfitted with the solid roller dual spring. We are good to go, so we'll get these on, and then we can start wrapping up this engine.
The mating surface between the heads and the valley cover must be sealed up so a decent bead of RTV is laid down. With our new 8.1cc valve relief piston and a 4350 by 27 thousandths thick gasket, our static compression ratio is now up 9/10 of a point to 11.64 to 1. The cylinder heads can be gently dropped on with one stud installed to help with alignment, and then the remaining studs can be screwed in hand tight to prevent aluminum galling into the threads. With ARP Ultra Torque lube between the washers and the nuts, the heads are torqued down in 3 even stages, ending at 80 pound-feet.
Our color-matched 4500 flange intake can go on next and is held down with stainless ARP intake bolts with thread sealer applied to prevent oil seepage. This larger manifold's ports line up perfectly with these heads, and we are expecting some big gains with this new setup. We will put high-pressure lube on the 9/400 long trend push rods and slide them into the engine, making sure they land in the lifter bucket. To install the rocker arms, we will roll the engine over so one side at a time has all the cam lobes on the base circle or just off the base circle, and then slowly and evenly tighten the Harlan Sharp shaft rockers down before torquing them to 35 pound-feet. We will set cold lash on this setup to 14 thousandths, and once we get the engine heated up on the dyno, hot lash will be set at 20 thousandths.
These vintage-looking valve covers can be tightened down with stainless steel studs to seal the engine up. The final addition to this engine is a Spartan but beautiful V-drive from CVF Racing with a mechanical water pump and one-wire alternator. Being all black, it ties with the engine nicely and gives it the perfect blend of an updated and modern look for this big inch Mopar.
Coming up, we hit the key on our stroker Mopar and tune it up for a big power increase with our new combination.
Our favorite time has arrived. We have our 505-inch big block Mopar on the dyno and ready to rock. Something we do to this engine and to every other engine is gap the spark plugs, and that is going to be the subject of today's Summit Tech Tip. Consistent spark plug gap is important for any application, and setting it to the right size is extremely important. But with these things that we have here on the table, relatively easy. First, we have wire gauge style, and these fit in between the ground strap and the electrode, and if it's too big, you can bend them actually with the bender that's included on there. You don't have to bash it on a table and potentially hurt the plug. Also a slider type, where if you slide it in, that's where your gap is. If it needs to be a little bit bigger, you just wiggle it out till you get the right size. Or for a more high-tech way to do it, we have this apparatus from Summit Racing Equipment. You take your proper gap that you get on a feeler gauge, you stick it in between the ground strap and the electrode, and actually squeeze it here on the handle. And when it comes out, it's a consistent gap every time. Keep in mind, the higher the horsepower, the higher the cylinder pressure, the tighter the gap has to be. And if you have a question on what plug you should run for heat range or what gap you should run for the application, you can contact the experts at Summit Racing Equipment.
Okay, 505's on the dyno. It is running, got it up to temp, check the lash, change the oil. We're getting our values programmed in, and we are gonna be making hits here very, very soon.
I'm very excited about this one, right? We've got a point of compression, right? We actually have a bigger header on it, but the big thing is that bigger cross-sectional manifold, that big giant carburetor and a big spacer. It's just all around. I think this is going to be very, very good as far as the power.
Shallow on timing right now. It's only got 30 degrees in it, so we're going to make a hit, see what it does, look at everything, and then we'll go from there. Let's make a hit on it.
Let her buck. That was evil right there.
I saw the numbers.
Yeah, pull that up.
Let's see here.
All right. So at 735.1, you know, that's at 6,300.
Yep.
665.7 at 5,000.
Fuel looks great on this car. I mean, this is a dyno carb, so we've ran this before. It's verified, tuned in and everything, but low fours for VSFCs. Air fuels look good.
I don't know who tuned that last.
I mean, it wasn't me, but it was someone in this room.
I used a typewriter on it. You know how you use
with a vacuum line
with a vacuum line hooked to it.
Let's do some tune on this thing. I want to see what we can get out of it.
Fuel looks good. We're gonna jack with some timing and see what we can squeeze out of her.
Let's do a timing loop.
Timing loop.
We will make several runs, incrementally increasing the timing by 1 degree until the engine stops gaining horsepower. which landed us at 35 degrees total.
All right, that's the final timing. I think that's all it's gonna take. By the way the plug looks and what the gas looks like in it, it's not gonna take anything more than 35. It's leveling,
Yeah.
it's gonna level off right there. So this is gonna be the grand finale right
Yeah.
here, but I think it's going to be impressive.
Yep.
760.8.
That's awesome. 677.5 pound-feet.
But man,
Wow.
that is mean.
And that's a big gain. So here's our gains
Pull
just
up.
from timing.
Yep.
I mean, that's big. Up top, what is that, 30? Is that
That's
close to 30?
Yeah.
And I mean, big thing obviously is that's like 95 horse.
Yeah, no,
you know, over the last
it
one.
sounds like a lot, but look what we've changed, right?
Yeah.
And what we've changed, it's doing what it should. It's printing the right numbers. So,
Yeah, I mean, you can see like manifold vacuum wise,
Yeah.
right now we're at 0.5 and before this thing was at 1.7.
1.7, so-
I mean, that's killer. That's
Yep.
that's a great combo.
I kind of feel like a Mopar guy now.
I know.
We are engine guys, but the Mopar fans, they're gonna like this one. So
If this is the Mopar, I'm a Mopar guy.
I'm Mopar head. Great success.
For more information on this build or any of the other cool builds we do here in Engine Power, check out Power Nation.